three. So the last 2 weeks, we went through a little bit of the details, especially the last week, as far as I remember, right? It was a lot of about compute engine, etc., etc. Now, what we're gonna do this week is we're gonna go through about managing and provisioning a solution infrastructure. So we're gonna go into more details, but for anyone that's joining just today for the first time, for the last week we shared the resources. If you're interested in the resources, please do drop us an email at the email that I have posted into the chat. For everyone else, welcome back, and we're gonna shortly kick it off. So we gave a little bit of a homework, right, last week for you to go through the details. Now, in interest of timing, what we're gonna do this week is that we will be go through all the slides because we have quite a lot to go through, and there's like a lot of details. There's gonna be some kind of like a practice questions, let's put it like, or exam discussion topics that we can go through. Those one will be with answers. We will elaborate the answers as well. And then at the end, well, I will not give out the end, right? Stefan will go into details at the end about whatever we're going to share as well. So without further ado, I will kick it off today, just because we have quite a lot to go through, right? So perfect. So preparing for the professional cloud architects. Glad to see everyone on this journey, but let's kick it off. So where are we at, right? So week 3 topics, as I have mentioned. So we're gonna talk about the Symbol Direct. So we have gone through their infrastructure in the past weeks as well. What is their requirements, both from a technical perspective, from a business perspective, but also their executive statement. So these 3 are very, very important, and be able to go through them, just because when you will need to answer questions onto the exam regarding a case study, you will need to have all these 3 into mind when you will need to actually choose the appropriate answer. Today, in addition to that, we will talk about the cloud storage and cloud SQL. And at the end, there's going to be a new case study analysis that Stefan will be guiding you through. So when we're thinking about the symbol, right? So when we need to provision any like a cloud solution, right? So switching to Symbol Direct for a bit, just to talk about, before we go into cloud storage, to talk about their configuring and provisioning, right, on their cloud resources. Now, as a professional cloud architect, right, what is our role? So our role, we need to understand the cloud services that are available out there on GCP. We need to be able to differentiate between them, and also we need to be able to select the optimal ones. So when we're talking about the optimal ones, we always need to consider the requirements when we're working with a customer. Those requirements can be the business requirements, those requirements can be the technical requirements. Now, we've already made some choices, right, in the previous weeks when it comes to this. Mainly it was about computing, if you remember. But today we'll do a little bit of we'll dig a little bit deeper, let's put it that way. But not just defining what to use, but also how to configure them, right? So what configuration choices we need to do? Sometimes it's actually quite challenging when you need to determine, right, how deep a professional architect or an architect would need to go when we're making a decision. So we are competent in many technical areas, but on the other side, right, we're not implementation engineers. We're not a data engineer, etc. So some of the choices that we kind of like, need to implement, it's actually performed from someone else. For example, that's why we have, let's call it this way, the cloud engineer role, where if anyone actually went through the associate cloud engineer exam, the associate cloud engineer more hands-on. You don't have any business requirements, don't have any technical requirements, but you need to actually answer details about how would you deploy X, Y, and Z. Now, today we will talk about a little bit about Cloud SQL, where within Cloud SQL, it's important to plan the deployment type because making decisions about, let's say, like the backup or high availability, it will actually not prompt us to design the database schema, but also we need to tune that performance using any kind of like a database flags. So there's a little bit of a kind of like a details of how deep we will need to go into that. Now, if we're talking about the actual Symbol Direct, right? Another example, which is like a more relevant for Symbol Direct, if you look at the slides over here, is that we have like a little bit of latency. So what that can be, for example, someone in the past when they were deploying like any solutions as well, etc., with Symbol Direct, they made not the optimal decisions about DNS. So that not optimal decisions resulted in like a quite a high latency for some communication. Now, we, as an architect, we should be able, or we should take this feedback from a customer, and instead of only like try to apply kind of like that lift and shift current solutions or lift and shift strategy, we should see how that we can optimize them by using any GCP resources. Like for example, load balancers, right? So we talked about this as well. So load balancers, but also any like a custom VPCs, when they are created with only like a selected regions, they can be created in those selected regions to reduce that or decrease that latency when streaming data, for example. But when we take these decisions, we need to also be able to enforce those decisions technically. For example, we don't. It's not enough for us to ask everyone like not to use a default VPC, for example, or not to create any VMs with external IPs, or not to create any resources in some distant regions where we don't have any uses. But we need to have a technical way of ensuring that those type of constraints are being followed. Now, we should be asking the question is like, does anyone know how to make this happen in GCP? So, and the answer is, yeah, there is a service, right, which will allow to actually for us to set this constraint. For example, we decided to set two constraint policies. One is skip default network creation, and the other one is restrict shared VPC subnetworks. What this will do is this will prevent a default network being created for new projects, but also ensure that resources are only deployed to approved subnets, reducing the possibility, right, of, in example of the previous example of those drone pilots experiencing latency. So when we go to the actual organization policies, right, and restricted, there are many more that are available out there, but also there are the most commons. Now, a direct example from the exam would be that, yeah, we should be familiar with these because some of them can be on the questions, but not just like because they will be on the questions, they also will be best practices when working with GCP. If you will have a question, for example, on the exam, what would be the best practice of this and this and this? 99% of that, it should be when it comes to like, let's say the VM external IP address, where you will be able to basically not allow them to create the VMs with external IP. So the answer would be, well, yeah, we should just enforce organization policy on that. Another one example can be restrict public IP licenses. And when that one is good, like when that constraint is set to true, then will not have a Cloud SQL with external IP address. This is going to be kind of like my personal feedback or my personal, I would say, regarding the exam, is that don't try and memorize all of them, because there are many, many of them. But most of them, the way I would do is most of them, they will be self-explanatory. So, for example, VM external IP address, very self-explanatory, right? SQL.restrict public IP, still explanatory. So just by reading with it, it will come naturally to us because we know that, well, resource is SQL, right? So Cloud SQL. Then what we'll do, the action is restrict our public IP. So those are the two different things we should be. Again, when we have like a require shielded VM, that will be on compute as a resource. So those are kind of like the associations that kind of like I would do, and but it needs to come naturally, because if we try to remember everything, or let's put it this way, if we try to remember all the documentation, then that's going to be like basically not a chance, right? So it's good to have actually a little bit of playing with those words around. Now, enough about the symbol, right, and everything. Let's move now to GCS, or Google Cloud Storage. It's always hard for me to kind of like pronounce that, just because I'm always like a cloud storage, never gonna that. Awesome. So the two parts of our session, the first one will be Google Cloud Storage, and the later one will be Cloud SQL. Now, let's start with the Google Cloud Storage. There are quite a bit that we need to know well, especially for the exam, just because there are many different flavors, let's put it that way, that we can have Google Cloud Storage. For example, object lifecycle, that can be object versioning, but also can be object lifecycle management. It can be mutable if they're immutable. What is the notification, storage classes, triggers, streaming uploads, etc., etc. We will not go into details right now, like all of that, but when you receive all the slides, you will see over there that there will be link related over there to any public documentation where you can read more about it. But we will try to cover them as much as possible as well during the next couple of Now, before we dive into that, let's go to diagnostic question, right? It is quite difficult, so we'll try to a little bit be use our, picking up the words in that way, right? So when we read, we want to highlight those words and try to choose whatever is the best, right? So your company has an application that is running on multiple instances of Compute Engine. It generates 1 terabyte per day of logs. For compliance reasons, the logs need to be kept for at least 2 years and need to be available for active query for 30 days. After that, they just need to be retained for audit purposes, right? So you want to implement a storage solution that is compliant, minimizes cost, and follows Google recommended practices, right? So let's do a little bit of a brainstorming together on the actual highlights, right? So it generates 1 terabyte per day of logs, right? Is it really matter for us? Does it really matter how much it generates if we know how much we can store in a storage bucket? Not. But there's a couple of things, right? So the logs needs to be kept for at least 2 years. Active query is only 30 days. After that is only audit. And we need to minimize cost and follow Google recommended practice. So what it will be. Do we write a daily cron job running on all the instances that upload logs into a cloud storage bucket? Someone says C. Then we create a sync into original, and then we create an object lifecycle rule to move files into a code lines cloud storage bucket after 1 month. Do we do a cloud logging agent on all instances, then create a sync to a BigQuery table, and then we set a time partition expiration of 30 days? Do we do cloud logging on all instances, then we create a sync to export to a regional cloud storage bucket, then we create an object lifecycle rule to move them to a code line after 1 month. And then we configure retention policy at the bucket level using bucket lock. And do we create a daily cron job running on all instances, upload logs into BigQuery, and then time partition expiration of 30 days, right? So what do we do? Someone said C, okay. So why it's quite difficult, right, on this one is because it requires us to know a couple of details. For us to know storage classes, for us to know sinks or the logging topic, for us needs to know the lifecycle rules in Google Cloud Storage, but also we need to know the retention policy. So I will just move on, continue. So yeah, C, it is correct, right? So A, we do a cron job, right? Is it Google recommended practice? No, but also do we have a retention for audit over here? Because all I see is that, well, in original and then lifecycle rule to move file, but there is no retention for audit, right? B, well, BigQuery, is it appropriate for audit only? Costs, right? We say minimize cost, but like cost. But also, do we have retention of data after 30 days? D, again, cron and BigQuery. So C will be the one, but we need to be careful over here, right? Because we can't have lifecycle rule and a retention policy on the same bucket, hence why we needed 2 buckets. So those are like, if you see it over here, we do a regional, right? And then we have a object lifecycle rule to move files into a cold line cloud storage bucket. So that's the other one over there. Awesome. So when we need to choose the location type, there is quite a few of them. Regional, it will be stored in a specific region. So we have a multi-region, which means that it's actually distributed across US or EU or EMEA or like Asia. And it can be actually dual region. So if we need kind of like a collocated compute and storage and automatic disaster recovery, this is what we will be using as well. So the exam tip as shown over there would be, we need to know the use case for each of those choices, but also that dual region buckets are not available for all the regions. So they're only available in selected regions. Now, a lot of them over here, right? So the storage classes where we have on cloud storage, or like, within the buckets that we will create, is that they can be a standard, nearline, cold line, and archive. So, so when we will have the exam, right, the exam will throw business requirements at us, right? So like before, it will be like, oh, we need to have them for audit purposes. We need to then like have after 30 days, they're only for kind of like archive purposes, something like that. It was mentioned, and we want to minimize costs. So those are like kind of like a business requirements, right? So we should, when we are looking at, we should always be able to read those tables from the bottom up. So what does it mean? What is the optimal storage class for backups? What is for disaster recovery? What will be for websites? Like for anyone who doesn't know, you can host static websites on Google Cloud Storage as well. So when we're talking about that, there's like a little bit of a this. But when you would go within like a more into actual documentation, there is more behind it. It will be any what any cloud storage class would be for when you would need to retrieve, because standard probably will be most expensive than archive, but the retrieval with standard is the least expensive than archive. So even though archive will be cheaper for you to store over there, if you need to retrieve that more often, right, then let's say like a archive would be like a less than a once a year, basically, if you think of it. So, but if it is more than that, you will need to go into cold line. Then if it is like you will be like a less than 90 days, but more than, whatever it is, then you would go to nearline. But if it is daily and stuff like that, then you will go into standard. So those are kind of like a differentiated to know about that. So here we are. So the details behind would be, what is the retention period and what is the access frequency? If it is more than 12 a year, right, which is like we like a regularly retrieve on that one and stuff like that, we would go with standard. Doesn't matter what's the retention period. You do retrieve data from there very often, so then it's going to be that. But then if you see over there, if it is between 1 and 4, but you need to have a longer, well, to have like a longer retention period, you go from standard to nearline to cold line. If it is less than 1 year, you start with standard, but then it goes to nearline, cold line, and archive. So that is behind about when you will have on the exam, for example, a question about, well, we need to also, minimize cost, etc., etc. But it's not just to know about how often you will access the objects, but also, you're right, it's how long we will keep them. So that is also important. We need to go. With colder classes, like we see over there, like nearline, cold line, and archive, we also have a minimum storage duration. So if you remove the objects earlier, you will still get billed for the remaining days. So when we need the planning, we should take that into consideration. Important to know, apart from all this, is that best practices on how we should load data from anywhere to our buckets. On the slide over here, it's actually shown the Google recommended, or like a Google's best practices to what we should use. If you see it over here, it's almost always best, like a practice or like a recommendation, is to use storage transfer service. But however, GSUtil, right? It's also applicable, but there is another one as well, which is transfer appliance, and transfer appliance should only be applicable or considered in specific use cases. So, for example, you have a private data center, or you have like a storage somewhere where you host a lot of data. You have not enough bandwidth. You have also a lot of data and not enough bandwidth, and sometimes those ones can actually be like taking like forever. Let's put it like that way. So yeah. Yes, there is good G-Cloud storage now as well. Correct. Yeah, GSUtil is the Python, right? So that's one as well over there. Perfect. Now, when you're talking about storage transfer service, that one can have like many advantages, right? So it can be set up as a recurring job. So when you set up as a recurring job, this kind of tool can be used of intermediate storage between your data on-prem or other cloud providers and the actual Google Cloud Storage service. But the actual location does not need to have like a Google Cloud Storage. It can be, for example, Cloud SQL. So that's like another part as well over there. So when you would need to fill kind of like the data coming from, for example, Google Cloud Storage, or they can be as well like a CSV files, etc., etc. There is another diagnostic question that we can actually perform now, since we know a little bit more details, which would be, your operations team currently stores 10 terabytes of data in an object storage service from a third-party provider. So they want to move this data to a cloud storage bucket as quickly as possible, following Google recommended practices. So they want to minimize the cost of this data migration. So which approach should they use? Should they use G-Cloud Storage Move, right? So to move the data, storage transfer service, download the data to a transfer appliance, ship it to Google, or download the data to the on-premise data center and upload it to the cloud storage bucket. What would be over here the kind of like a best answer, or what would be like which approach we should take? We should be following like Google recommended practice, right? Someone says C. So we want to move that 10 terabyte of data to cloud storage as quickly as possible, following Google recommended practices. I see a couple of C and a B, and the answer will be B, right? We would use the storage transfer service for that one. If 10 terabyte of data, which when you would go online and read about that, 10 terabyte of data is actually not a lot of data. Transfer appliance, it's actually used for petabytes of data mostly. There's a couple of them over there, but basically, what happens is that you would actually go and order it because you will have a large data and it would take quite a long for you to upload it. So you would order it, they will ship it, and it's actually your data gets encrypted. You transfer it over there, then you ship it back. Then they would upload it to your, and then you would kind of like sync whatever is the rest. So perfect. Let's go to another one. So the 10 terabyte on-premise database export into cloud storage. So you want to minimize the time it takes to complete this activity, the overall cost, and database load. The bandwidth between the on-premises environment and Google Cloud is 1 gigabit per second. So again, we follow Google recommended practices, and what should we do? Do we develop a data flow job to read data directly from the database and write it? Do we use data transfer appliance, offline migration, use a commercial partner ETL solution to extract the data from the on-premises database and upload it into cloud storage, and compress the data uploaded with GSUtil to enable multi-threaded copy? So a couple of highlights here we want to get, right? So we have that database export. We want to minimize the kind of like the time, but also we want to minimize database load. We want to also minimize the overall cost. Someone is leaning towards D, another one D, cool. So what do we do, right? So perfect. So let's put it this way. Yeah, D would be the one, right? Why? Well, A would affect database load, right? So it's not applicable. B, it's not cost effective. And also it takes 2 to 3 weeks at least, if you use the data transfer appliance. C, it's not effective as well, and it will take a long time to arrange everything. But also, don't you feel that one, it's like very overly complex for copying a database export? So that's why we would use D. So we'd use GSUtil to move that data across to Google Cloud Storage. Awesome. Now, in the next slides, we have the details from the, I found this kind of like a one slider, right? Very good, let's put it that way, like on that side. So what do we have over here, right? So we have all the options together. So we have the Google Cloud Storage transfer tools. Then we have a transfer service. Then we have transfer appliance. And then we have that BigQuery data transfer service. So all of those ones, how do they work? What is good to know? So those good to know things is the ones that are actually quite good when it comes to the exam. The actual, I remember actually like that all the GSUtil, right, will be like, okay, so you do upload, you need to have a good, bandwidth and stuff like that, blah, blah, blah. But also you can do a fast multi-thread. So it's kind of like that side. So if you need to have data transfer, what are the use case, right? Usually that you would do, what you would leaning towards to. When it comes to transfer appliance, if you see it over there, right? Well, large scale transfers from low bandwidth network. So when you would do get like a question over there and you would need to think about it, it's like, well, it's a large scale transfers, it's a low bandwidth, and usually it's a no-brainer that we would need to use a transfer appliance. Unless, it will kind of like specify, because with transfer, like we see it over there, right? We will have like let me just go back, a commercial partner ETL solution, right? So we have data transfer appliance, then we have commercial partner. So both of these ones are not cost effective in our case, but one is more cost effective than the other one. But also, what is quicker when it comes to that? Like, for example, the commercial partner ETL solution, it takes long to arrange everything. and usually it's like overly complex. So auto reactions. So on the auto reaction from like when it comes to like object changes, there are three different, well, kind of like three options we can use. This is all to create some automatically triggered workflows. So, for example, if you have a cron job that would execute like 10 minutes to check if a new object was uploaded, you will have some more of like a cloud native. So, if you would run a job every 10 minutes just to check if something was changed, it will not be cost effective, right? It's a little bit of expensive, let's put it that way, because you waste resources and there might be no changes at all, you know? So, yeah, so let's put it that way. What I would use when it comes to that one. So we have pops up notifications, we have object change notifications, and we have cloud functions, right? So if we would need to execute or like a trigger something on our in our cloud environment to be completed, we would use a little bit of a triggered workflow. Let's put it that way. So if we have, for example, a new object uploaded to the storage, where the Google Cloud Storage service would generate pops up notifications when that like a new object arrived. So this can also be used for you to trigger a cloud function. So when you trigger cloud function to fetch the actual object and perform some actions on it. There's a couple of over there that are divided in, but the exam tips would be if you are to distinguish between them. Object change notifications, they're not the optimal because they are slower, meaning like, the actual notification takes a little bit of time, but also they're not that flexible because the object change notifications is actually done on an object, but you can set up, for example, to a pops up, which is 101, you will set up to send a pops up notification when that any new object arrives or any object was changed, and then that pops up will will generate that notification and then will trigger like a cloud function on that side. So with this in mind, let's go with the actual diagnostic question. So your company says create an application that uploads a report to a cloud storage bucket. When the report is uploaded to the bucket, you want to publish a message to a cloud pops up topic. You want to implement a solution that will take a small amount of effort to implement. So what do we do, right? To create an App Engine application to receive the file. When it is received, publish a message to the cloud pops up topic. Configure a cloud storage bucket to trigger cloud pops up notifications when objects are modified. Create a cloud function that is triggered by the cloud storage bucket. In the cloud function, publish a message to the cloud pops up topic. Or create an application deployed in a GKE cluster to receive the file. When it is received, publish a message to the cloud pops up topic. All right, so we have quite a few, right? With a BBB, which is kind of like a very easy answer, right? Because do we create an App Engine application just to receive that file? Do we create actually a GKE cluster to receive that file and then publish to cloud pops up when you can just configure that cloud storage bucket to trigger that pops up notification when objects are modified? So yeah. Awesome. So how to use a customer supplied encryption keys. When you have like a Google Cloud storage, right? So Google Cloud Storage is one of only two services where you can use customer supplied encryption keys. Um, the other one, if you remember from the last time, is the persistent disks. So persistent disks is you can use the customer supplied encryption keys. Um, so for the actual exam, this is like a steps over here, like procedure and stuff, etc. But for the actual exam, you might get like a question about how would you use a customer supplied encryption key in a practice, or you can get like a question of how like about the format actually of encryption key that is required. So yeah, so remember when it comes to that, it's AES 256, and it's additionally encoded with base64 encode. So um, those are details. Now, for cloud storage and the ones that we previously mentioned at the beginning, that us being a cloud architect, right, we would go through details of how we can enforce certain things. So the most important organization policy constraint are listed over here, and it's good to actually know this and remember, because if we want to do, for example, enforce public access prevention, this is what we should do. We should have the constraint of storage dot public access prevention, and that way you will be able to prevent, from being accessed by the public internet. So we would actually disable, right, and block that. But remember the organization policy constraint. It's not just the only defense, right? We need to work together with IAM. All the organization policy constraint, as you mentioned over here, will block or disable the IAM permissions that will grant to all users and all authenticated users. We still, on top of that, need to have an additional IAM policy in place to ensure that only the relevant users or the relevant services should able to make changes or edit the file stored over there, even for a read or an execute. Now, to wrap up this Google Compute Storage topic, it's a little bit to share like a little bit of final kind of like a useful thing. So if you have a customer that we want them to migrate their Hadoop workloads to Dataproc, if you remember from our last week, Google Cloud Storage will play a role here as well. So because the Google Cloud Storage will be a replacement for HDFS, and it's actually a preferred setup in most cases. Now, we're not going to go do a full details about like migrating HDFS to GCS, but when it comes to the dependencies between storage and compute, GCS is what is going to be used for those HDFS. The bottom line, let's put it that way, is that you can't scale with HDFS because storage is still tied to compute. So if you go into a little more details, not only that, like HDFS will be like a very price resource, right? With we are also like a changing over here that, well, it will be the very pricey resource, the compute, but we will change it with a relatively like not that expensive resource storage. But also when we were having Google Compute Storage, it will silo that data in a single cluster instead of exposing it to all the possibilities like offered by GCP. Now, there is a quite of reasons why you would use like a HDFS on like a Dataproc, for example, local SSDs, etc. But those purposes should primarily be limited to temporary data, such as shuffle data, etc., etc. Don't need to remember like all of that, but hey, this slide is kind of like what we're gonna conclude on the Google Cloud storage. But let's see if we before we go to Cloud SQL, let's see if we can get a little bit more, or like if I can remember any other question. So on the details behind that, if we think about, so what do we need to know from so far, right? So we need to know that we can deploy a bucket with different scope. It can be region, but also multi-region. What is the most cost efficient, right? That will separate buckets between them. Some additional replication between them. We need to also watch out for compliance, GDPR, right? That's also depending on how you would define the buckets. We can lock policy on the bucket as well. But one thing to remember when we lock policy on the bucket is that after locking, we can't remove the lock. And buckets or Google Cloud Storage is good for long-term storage for audits, but also needs to be kind of like a carefully implemented when it comes to that. Perfect. Now, let's move a little bit of Cloud SQL. With Cloud SQL and GCP is managed databases. But before we dive into that, right, and why would we even want to use any managed databases in GCP? For all we know, right, and for all we can think about is that, well, I can deploy a MySQL on Compute Engine on a VM and then just run it over there, right? So why would I want to go with any of like managed databases option in GCP? Well, we can deploy almost anything on a VM, probably, right? So we can probably deploy anything on a VM, but then we are responsible to basically most of the technical tasks that are needed to configure, but also to be maintained, such as it. So when it comes to, so one thing to know, right? If you see like over there on the bottom, one thing to remember is that unless we have some very specific requirements, the actual, databases on VM. So if you think about it, if you compare it to the managed one will always be the preferred option on an exam. So unless we have some specific requirements. So if anyone has an idea, like what would you think that would be like a specific requirement? Why would you choose to deploy a VM and prepare everything from this level? Like if you over here, configure, patch, handle high availability, blah, 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 instead of just using a custom solution, right? If anyone has an idea, but I could tell you like, well, managed databases, Cloud SQL is managed. So if you see it over there, everything that we can see it over there, it's going to be like managed by Google or by GCP, right? One thing as well is that not all features and plugins are supported. So if it is a requirement for some unsupported features and plugins, that those ones will be, you will have deploying on VM instead of Cloud SQL. If you would need a specific database engine or version of that engine, yeah, perfect as well. Specific OS needed as well. So if you have some custom backup and restore requirements, when you need like a lot of flexibility, yeah, so those are kind of like the ones that you would do. Well, for example, if you need only if you need like lift and shift, so if it is required to be a lift and shift, that will be as well. For example, you would move them from on-prem to GCP. So you would do a lift and shift, but then you would think about long-term because the requirement is there for that project. But then long-term, you would actually move forward and move them for like any managed, like we're talking about here, Cloud SQL. So, but in most cases, right, we would choose a managed solution, which is the one as well that's like a preferred approach from an exam perspective, because that one offloads most of the responsibilities to GCP. The managed solution actually removes 90% of operational efforts, right? So if you see it over there, the availability is 99.999% of SLA. That's yearly. And I don't have the numbers in front of me. Someone has, please do add them into the chat. But basically 99.999% yearly is like minutes of downtime per year or something like that, if I remember, because I had recently talking about SLA and SLO and 1.9 over there. So it's a good kind of like outside of the scope or a little bit over here, but it's a good approach if you could check what is the difference between 99.9, 99.99 and 99.999%. Thanks, Ian. So 5 minutes and 15 seconds of downtime per year. So that's like the SLA, which is, I don't know if I should use the word, but kind of like a madness, right? So, right. So first thing we should be aware is the high availability, right? So high availability is super easy to set up. So we're always going to have like instance running in a single region, but it's going to be across 2 different zones. And those ones will be active passive. So if we think about it, before we were talking about active passive would be that active configuration is that one always serves it like read write, the other one just waits if something like goes wrong to the other one and then switches over there for a fully automated failover. So that one between them, it's based on synchronous storage replication. So in an event of failure, there will be no data lost as well. So the purpose of like a high availability configuration is to reduce the downtime when a zone or any instance becomes unavailable. So high availability configured instances, they are charged the double price of a standalone instance. One thing to note as well. But if you see it over here, if the heartbeat is unavailable for 60 seconds, do boom, automatic failover. So those are the data. Now, I have a couple of slides before possibly we can do a break, maybe a couple of minutes break before we continue, because we are almost at the half of it. So let's do this one, right? Remember, what is the preferred answer on exam? You need to set up a Microsoft SQL Server on GCP. Management requires that there's no downtime in case of a data center outage in any of the zones within a GCP region. What should you do? Cloud Spanner instance with a regional instance configuration, SQL Server Compute Engine using always-on availability group, using Windows failover clustering, place nodes in different subnets, configure a Cloud SQL instance with high availability enabled, set up SQL Server always-on availability groups using Windows failover clustering and place nodes in different zones. What would you do? When you would deploy Cloud SQL, right? What is the what flavors or versions are supported? Cool, nice. So I see a couple of answers over there, which is great. Oh, I lost the chat. Here we are. So we have C, some D, and C. Well, yeah, the answer will be C. So we configure Cloud SQL instance with high availability enabled because we just set up a Microsoft SQL Server on GCP. There's no downtime in case of a data center outage in any of the zones within a GCP region. So that's the one that we would, set it up. Microsoft SQL has like a couple of limitations, let's put it that way. One thing as well is that because everything runs on Linux, so SQL as well, like over here, we're talking about, on Cloud SQL, Linux or Unix, whatever you want to call them. So if you need to have some features that are only supported on Microsoft SQL on Windows, then, you will need to set up a SQL Server Compute Engine. But just because here it doesn't go into details, we don't have anything. Once just requires no downtime, right? and there is nothing else. So we're just gonna be like, yep, that's fine. We're just gonna configure Cloud SQL instance because it's the preferred option. We don't have anything over here that will say otherwise. And lastly, it will be probably the easiest route for us to do. Awesome. Now, those are the details behind from my side. We're in the middle. Stefan, what do you say? Do we do 5 minutes break and we come back for the second part?
Yeah, I was actually thinking about the same thing. We can do 5 minutes. Let's do, yeah, 7:01, just to give them 5 full minutes. Tea, water, whatever, and then we can kick off with the rest.
Sounds good. Awesome. I'll
Cool.
see you back in 5 minutes.
Cool. Cool. So, hi everyone, welcome back. Hopefully, you had some tea, some water, some. I think it's quite late for coffee, but maybe some of you would like some coffee. Yeah, so we're just gonna kick off with next, which we are looking at Cloud SQL, replicas. So we're gonna look first. I need to put my head like this because this diagram is the other way around. Hopefully, you're not gonna break your neck. So, in parallel to high availability, we can scale. Sorry, we can scale our architecture using read replicas. There are two primary reasons to do this. First, for disaster recovery, as replicas can be created in a different region than the original one. And secondly, the offloading read-only workloads. For example, heavy analytics would be in this situation to keep our primary instance fast. So for Cloud SQL, for MySQL, we have two main configurations here, standard and external. So for the standard read replicas, they are managed within the Cloud SQL, similar with what we see in Postgres. And external read replicas, this is a unique hybrid setup. The primary instance runs in Cloud SQL, but the replica runs on premises, essentially self-managed. This is great for on-prem applications that need low latency access to data without constant round trips to the cloud, essentially. So there is a challenge, replication lag, for example. This is the delay between write on the primary and that same data appearing on the replica. If the network on-prem goes down or gets throttled, this lag can become so large that the replica has to be completely recreated. So to combat this in MySQL, there are a couple of versions here, 5.7 and 8. You can enable parallel replication. By increasing the number of SQL threads, the system can execute multiple transactions simultaneously, significantly reducing that lag. So a key takeaway for the exam would be that because GCP's VPCs are global, you don't need complex network adjustments to create replicas in different regions. Also, something to remember that Cloud SQL replicas are always readable. So you don't need to choose between disaster recovery or read-only offloading. You automatically get both capabilities with one replica you create. Now, moving next on to the next slide. Now we have the inverse of the previous setup. Replication from an external master. So in this scenario, your primary or master instance is self-managed MySQL database running on premises. So this is happening while the read replica is created within the Cloud SQL. So there are two main reasons why you should choose this configuration. First, to offload administration. By putting the replica in a Cloud SQL, you offload the management and the maintenance overhead of that specific instance to Google. This allows you to keep your primary focus on the on-prem master. Second, for migration, this is a powerful path for migrating databases from on-premises to GCP with minimum downtime. The workload for migration is straightforward. You create the Cloud SQL, read replica, and let it sync with the on-prem master. Once the two databases are fully in sync, you can promote, let's say, the Cloud SQL replica to become the new primary instance and simply redirect your application traffic to it. Again, important aspect for the exam. For MySQL, this setup provides a clear migration path and allows for parallel replication on the read replica side. So for the PostgreSQL, Postgres, you'll notice the mention of DMS, which is database migration service. This is used to replicate for an external server to a Cloud SQL replica, whether for one-off migration or continuous data replication. The source can be self-managed on-prem or even another cloud provider like AWS, Aurora, for example. So next we will have, I think those are one of your favorites. We have some diagnostic questions actually. Let's see. So during a high traffic portion of the day, one of the relational databases crashes, but the replica is never promoted to a master. You want to avoid this in the future. What should you do? A, use a different database. B, choose larger instance for your database. C, create a snapshot of your database more regularly. D, implement routinely scheduled failovers of your database. 1 minute. Okay, David, D, Yusuf, D, or can I call you Ola? Thank you. Okay, Ola, yes, D. Anyone else? Okay, cool. Mustafa, well done. D. I think pretty much everyone is clear on this one. Yeah. So the answer for this it's D. You need to remember here that the failover is not automatic, and you need a working procedure to initiate the failover. Moving on to the next one. Yeah, there are some links here. Obviously, all the links that we do have, we're not going to go through them or share them now, but as Goran and myself have mentioned quite a couple of times, we will share the slides with you, and the links will be there as well. Okay, so building, what we're doing next, simplify migration with data migration service, DMS. Yeah, so this is this is what I've mentioned before. So building on the migration idea we just discussed, I want to highlight a specific Google service called DMS. Again, database migration service. So the main goal of DMS is to provide continuous migration path to Cloud SQL while maintaining minimal downtime. It's designed to be the simplest way to move your data because there's no migration service for you to manage. It uses native replication methods and has baked-in configuration support to handle the heavy lifting for you. The process, it's largely replication based. So you initiate the replication while your client database is still up and running. You wait for both ends, your source and your new SQL instance, to become fully synchronized. And the last step here would be to you plan like a cutover with a very short downtime window at a time that works best for your business, most probably during the night, or that's yet to be determined. So essentially the DMS allows for time and effort optimized migration for MySQL, Postgres, SQL, server like MSSQL, through though keeping in mind that there are some version-specific restrictions in here. So a few technical notes would be to keep in mind would be that currently support for MSQL, it's in beta. DMS also supports scenarios where you source database in a managed service delivered from other hyperscalers like AWS or Azure. And it provides secure correction options for encrypted data and uses private networking to keep your data safe during the move. So important for the exam, you don't need to be an expert in DMS, but just essentially be familiar, have a high overview, and the primary tools for these types of managed migration. You might have some questions over there. I'm not 100% sure how many, but just be familiar, have an idea. And even if you don't know everything, you can actually look and scan to the knowledge that you have and say, I want to do an elimination process. And that should be fine. Cool. Let's move on to the next one. So we need to look at how we create these replicas. We're going a bit more deeper here. So in the let's look how we create them in the console and some important rules to keep in mind. So first, it's vital to understand that the replicas are separate instances. There aren't just settings on your primary databases. They have their own resources and can even be configured for high availability themselves. I remember someone was asking about this earlier on. This means that your read-only traffic can also benefit from the same level of redundancy as your primary instance. So as we're having a look at the slide, you can notice here that we can create something worth mentioning is that we can create up to 10 read replicas for a single Cloud SQL instance, and these replicas are quite good. They're versatile, to be honest with you. They can be used for disaster recovery or to serve dedicated read-only applications. So, however, there's one very important operational detail that you must remember for both the exam and real-world management, because essentially you're going to pass that exam and you might be in a situation where you have to use this. So you cannot stop primary instance if it has a read replica. If you're trying to optimize costs by shutting down a primary instance, you'll find the option is block until you deal with the associated replicas first. So just a few tips for the exam. As usual, replicas can be made highly available, HA. You have a limit of 10 replicas per read-write instance. For my SQL specifically, you can actually create additional indexes on the read replicas that don't exist in the primary, which essentially it's great for specialized reporting. So that's pretty much it on this bit. So we're going to move forward with this, and just going to say a few words about instances, Cloud SQL on the edit instances. So once our Cloud SQL instance is up and running, we have the flexibility to adjust its configuration as our workload grows. So many of these changes can be handled directly in the Cloud console, which you can use essentially gcloud SQL instances patch command. If you don't know, it would be great to familiarize yourself with those. And there's a very important distinction between modifiable and what is fixed. So we're gonna talk a bit about what we can change on the fly and what we cannot change, and especially what we cannot change. This would be quite vital for the exam. So the first category, what we can change on the fly, would be for machine series and size. So we can scale our CPU and memory up and down to match performance needs. High availability, we can enable or disable high availability at any time after creation. Storage capacity, we can increase our storage manually, or better yet, even enable storage auto growth for the instance scales itself as it fills up. Network settings, we can toggle public or private IP and update authorized networks. And the second category, what we cannot change, instance ID. So usually, I think this is a no-brainer, to be honest with you. Usually the IDs in many aspects cannot be changed. So yet again, here as well, cannot be changed. It's permanent. Region, you cannot move an instance to a different region. You will have to migrate it. Database version, you cannot just simply switch versions. While major version upgrades are possible via in-place upgrade process, you cannot, for example, switch from MySQL to Postgres. The storage type, you must choose between SSD and HDD at creation. You cannot swap them later. I think I've explained last time about SSDs and HDDs. Storage reductions. So while you can always increase storage, you cannot decrease it. If you ever provisioning a disk, there is only one way to shrink it. It's essentially to export the data and import it into a new, smaller instance. This process reminds me about HubSpot. If any of you have actually used HubSpot, when you have to create what's it called, active or static lists. Active lists, you can add as many contacts as possible, and static lists, they do essentially have a specific amount, a set amount that it cannot change. So if there is something that you don't remember regarding this situation, you can essentially just use analogies or something to take you there. So one final tip for this: if you use regional persistent disks, remember that their size cannot be reduced. So always start with what you need and let auto growth handle the rest to stay cost effective. What do we have next? So we have Cloud SQL, performance and scaling. So now let's talk about how we actually scale these instances as our needs grow. So scaling in Cloud SQL is straightforward, but you need to be aware of when an operation will cause a brief service interruption. So in order to scale your Cloud SQL instances, compute power, you will need to resize its resources, specifically CPU and memory. It's important to remember that changing machine types requires a restart. So you will want to plan this during maintenance window, so you won't have any situation over there. So storage behaves differently. Increasing storage does not require a restart. You can scale your disk capacity whilst the database is fully online. And even better, since we've been mentioning about storage auto growth, you can enable this, and this setting allows the system to automatically add more space whenever free space hits a low threshold, preventing out of disks error without any manual intervention. So important, again, a key aspect for the exam. Just have this, should we call it a formula maybe? A plus B equals C. In this situation, scaling CPU or CPU memory equals restart required. This just have this thing in your mind. So scaling storage, there's no restart required, and crucial limitation where you can easily scale storage up, you cannot decrease it, as I've mentioned before. So if you provision too much space, you are stuck with that size and that cost implicitly. Unless, again, when you have to migrate to a new smaller instance. So that's a key takeaway. Yes. Ian it's literally spot on. He's saying it's a nightmare. Sorry for you, Ian. Cool. So let's just move to cloud. Still on Cloud SQL, but we have GCP native backup and restore. So on this, let me just So let's talk about this. Let's talk about data protection through GCP native backups. So Cloud SQL provides a fully managed backup service that's quite different from a standard database export. So by default, every instance is set for automated daily backups. This occur with a specific 4-hour window that you can choose, usually during your lowest traffic period. Again, we've been speaking about downtime and when to organize this the best. Cloud SQL retains 7 of these automated backups by default, though you can configure this to keep up to 360 days of history. So in addition to schedule, you can trigger on-demand backups at any time. Those are useful before a major application update or schema change. Unlike the automated ones, on-demand backups are not automatically deleted. They persist until you manually remove them or delete the instance itself. So important operational details to remember on this: it's instance deletion, backup versus export, and restoration rules. So for instance deletion, if you delete a Cloud SQL instance, its data is only preserved for 4 days. After this is gone. So be very careful with the delete button. As usual, there's no recycle bin in this situation. Backup versus export. So these backups are managed by Cloud SQL and stored separately from an instance. They are different from exports, which are files you manually save to cloud storage. And restoration rules: you can only restore a backup to an instance running the same database version. You cannot use a backup to perform a version upgrade. So another tip from me here: be sure to distinguish the backup window, so essentially when the backup starts, and the maintenance window, when the instance might restart for updates. Essentially, they're not the same thing. Right. So point in time. So beyond standard daily backups, Cloud SQL offers a powerful safety net feature called point-in-time recovery, or PIP. I think me and Goran have the same thing today. There's some situations when I generally cannot pronounce, or I find it very hard to pronounce. But let's just say PITR. Okay. This allows you to restore an instance to its exact state at a specific second in time. Think of this as an undo button for the database. It's a critical error or accidental data deletion occurs at, 2 p.m., 2:05. You don't have to settle for yesterday's backup. Instead, you can restore the database at 204, so in 50 seconds. Let's just say this specific example. Essentially, you're losing virtually no work. So technically, this works by using transactions logs, like the like binary logs in MySQL, or write ahead logs in Postgres that records every single change happening between your regular backups. So there are three key things to remember about this. It must be enabled. You have to toggle this option on when creating the instance, or in the settings for it to be available when you need it. Storage impact, because the system is keeping a detailed log of every single transaction. It does require a bit of extra storage space. Of course, it needs to go somewhere. Recovery creates a new instance. So when you perform a point-in-time recovery, Cloud SQL doesn't overwrite your current database. Instead, it creates a brand new instance at that specific point in time, so you can verify the data before switching your application over. So essentially, this would be the primary defense against human error or application bugs that corrupt data without taking the whole system down. I think this point-in-time recovery, I think it has been inspired by some time travel movie. So if you do tend to forget all this process and how to approach it, just think that you do have, let's just say you have a watch, for example, and then if you press that button, you do have the possibility to go back in time at that specific time and recover all your data. I think in a nutshell, it's very easy to it's like this, and it would be very easy to time travel. Yes, I'm saying this because yes, snapshots in VM. I'm saying this because I find it much easier to associate technical knowledge examples with real life examples. It's just makes it way more easier for me to understand processes, cloud native technologies, programming languages, and so on. Cool. Enough about time travel on this. So I think we should look at data export. So for this, we can move forward onto the next slide. So for data export, the final method of protecting and moving our data, it would be this. While backups are managed by Google for disaster recovery, exports are manual or scheduled tasks that send your data directly to this is the word that Goran cannot pronounce. GCS bucket, Google Cloud Storage bucket. There are two primary formats we use for this exports, essentially. So SQL and CSV. I'm going to give you a few words about SQL and CSV. Essentially, it would be high fidelity dump of your database. It's best for full database restoration or moving data between cloud SQL instances. And CSV, this is a database agnostic format. It's much more flexible and is typically used if you need to ingest your data into another tool like BigQuery, or even move it to a completely different database provider. I know that because I actually use this CSV, and yeah, I can use what's the other one called, XLS or XLSX, but mostly I use CSV when I import a lot of data onto HubSpot. I've done some integration onto HubSpot, and I've been testing with some active and static lists that I've mentioned before, and CSV, it's absolute friend. The other way around, HubSpot, it's a very good friend with CSV format. So definitely, if you're gonna look into that, make sure you make a choice. So One powerful feature to note is that you can export data into buckets in different projects. As long as you have granted the Cloud SQL Service account the correct write permissions for that specific bucket. Again, on this, a tip important for the exam. Cloud SQL backups are for recovery within Cloud SQL, but exports are for portability and long-term external storage. So if you need to automate these exports on a regular schedule, the best practices is to use Cloud Functions combined with Cloud Scheduler. This allows you to create a hands-off custom archival system that fits your specific retention needs. Next, I think we can do some, we can do some diagnostic questions. Cool. So let's see. You are implementing a single cloud SQL, MySQL. Second generation database that contains business critical transaction data. You want to ensure that the minimum amount of data is lost in case of logical data inconsistency. What should you do? Sharding, read replicas, binary logging, automated backups, or semi-synchronous replications. Should we maybe give a tip here? Maybe. There are two correct answers here. B and D, C and D, C, D, okay. DC, okay. Yeah, I think majority of you have been spot on this. So the correct answer is, drum roll, yes, C and D. So essentially, D, binary logs recovery. Binary logs record every change, insert, update, delete, so on, made to the database after the last backup was taken. So by combining automated backups with binary logging, you can perform point in time recovery. So this allows you to restore at the exact point in time. And D, this provides the foundational snapshots of your database at a specific point in time, usually daily. It's a catastrophic failure or massive corruption. If a catastrophic failure or massive corruption occurs, you have non-good state to return to, essentially. I'm not going to go to the wrong ones. I think we can just move on. We have any more? No, we don't have diagnostic questions. So for this one, let's talk about how our application actually communicate to databases. So there are several ways to connect, and choosing the right one depends on your security requirements and where your app is running. So as you see on this table, we have three main pillars of connectivity: public IP, authorized networks, of course. This is the simplest method. You allow external IP address to bypass the firewall. However, it requires you to manage SSL and TLS certificates yourself for security, which adds manual overhead. Private IP, this is the most secure and performant option. It uses VCP peering to keep all traffic with Google's private network, avoiding the public internet entirely. Yeah. Cloud SQL auth proxy. This is a small helper application you run alongside your app. It handles all the complex parts, authentication, encryption, and certificate rotation automatically. Again, important for the exam, the GKE solution, when you see a question about connecting a GKE cluster to Cloud SQL, the Google recommended, or Google way, answer, it's always use Cloud SQL auth proxy. So in GKE, you typically deploy the proxy as a sidecar container, let's say, within your application pod. For better security, you use workload identity to give your Kubernetes service account the specific YAM, identity and access management permissions. It needs to access the database without using static keys. For modern large-scale clusters, you might also mention about Cloud SQL Auth Proxy Operator, which automates the sidecar configuration for you. So just to summarize this in one sentence, if you're in the cloud, use private IP. If you are on GKE or need easy security without managing certificates, use auth proxy. So that's pretty much it on this bit. So when setting a cloud, when setting up Cloud SQL, you have to decide how your application will find the database. You can choose private IP, public IP, or both, as we have mentioned. I have mentioned before. It depends on your network topology. So first, let's look a bit at private IP. This is the preferred option when your clients are coming from a resource within internal visibility, like a VM or GKE cluster within the same VCP. The benefit here is that it provides the lowest possible latency because traffic stays entirely within the Google's private network, and it never touches the public internet. So the way to set this one up, it's enabling this. It would require private service access, which essentially uses VPC peering to connect your network to a Google managed service producer network. On the security side, you can further secure this internal connection using Cloud SQL Auth Proxy or self-managed SSL certificates. Now, next, there is public IP. Use this if you need to connect from clients outside of the Google Cloud VCP network. On the requirements here, to keep this secure, you must authorize specific external networks, like whitelist IPs, or use Cloud SQL Auth Proxy to tunnel the connection. Now, again, something for exam and important. A Cloud SQL instance can actually have both a public and a private IP addresses simultaneously. So if you configure your private IP, remember that it relies on private service access via VPC peering. So this is very common technical question. And a tip here, if your security audit requires no public internet exposure, you should explicitly deselect the public IP checkbox to reduce the attack surface. Right. Next, public IP risk mitigation. This is important, same as the other ones, of course. When we when we enable public IP on a Cloud SQL instance, we are essentially placing it on the internet. So without the right protection, this is maximum risk scenario for your data, because it becomes a target for automated brute force attack. I hope you understand how brute force they've been executed. So to mitigate this risk, Google provides two primary defensive layers that we should always use together in tandem. So authorized networks, IP whitelisting, something we've mentioned before. The first line of defense is to define the unauthorized network domain. This ensures that only trusted IP addresses or CIDR ranges can even reach the database portal. So, as a rule, never use 0.0.0.0/0, as this whitelist the entire global internet. So the range is huge. Instead, restrict this to your specific office, data center, or application server's IPs. We'll be mentioning about SSL and TLS. So the SSL and TLS certificates for transit data. So whitelisting an IP address only controls who can connect. It doesn't protect the data inside the connection. So by enforcing those SSL and TLS encryption, you ensure that credentials are query results that cannot be intercepted for man-in-the-middle attacks. So we've been looking at brute force, man-in-the-middle. Slowly we're going to cover everything. So to set this up, you must download Server CA certificate from the console and configure your database client to require it. So for higher security, you can enable mutual TLS, which requires the client to present its own certificate back to the server. Again, a tip for the exam, just having an SSL certificates isn't enough. You must still add client's IP to the authorized networks list for a direct public IP connection to work. So, however, if you use Cloud SQL Auth Proxy, it automatically handles encryption and identity verification for you. So making this manual certificate steps unnecessary. So just have a look there. So let's look at private IP configuration now. This is a gold standard for security practices. It allows your resources like Compute Engine VMs or GKE pods to reach the database using internal IP addresses without even touching the public internet. So there are some categories which we're going to go through. Some key characteristics would be connectivity is established during VPC network peering. When you enable a private IP, a peering link is created between VPC and the Google Managed Service Producer network where Cloud SQL actually runs. This setup is ideal for connecting your database to GCE or GKE instances securely. The benefits here are quite clear. So low latency, improved security, lower cost. For low latency, you get the best possible performance by keeping traffic on Google's private fiber. For improved security, your database is never exposed to the public internet. So significantly reducing the attack surface. And for the cost, you avoid standard internet egress cost because the traffic remains internal to the network. There are some critical limitations to remember. So peering quota, there's a maximum of 25 peering connections per VPC network. No transitive peering. So peering is not transitive if VPC A, for example, is paired with VPC B and VPC B is connected to Cloud SQL. VPC A cannot reach database through B. Make sense? No overlapping IPs. So the subnets in your VPC cannot overlap with the IP ranges used in the Cloud SQL. Again, An exam tip here. Let's say if a question asks you, if you get a question that is asking you how to connect two VPCs to the same Cloud SQL instance, remember that standard pairing won't work due to non-transitive rule. You need a more advanced solution like SOCKS 5 proxy or private service connect. Right. So I think here, Cloud SQL. So while we discuss authorized networks and SSL certificates, the most recommended way to connect, especially for production, is the Cloud SQL auth proxy, which I've mentioned this thing already. The proxy operates on zero trust model. It assumes that no direct connection is trusted. Instead, every connection must be authenticated and encrypted through this specific tunnel. How it works? It runs a local client in your application environment, like a VM or a container, alongside the companion process on the server. And your application talks to the proxy using standard database protocols as if it were in talking to the local database. Cool. So I think next we have some diagnostic questions. I know you love these ones. So let's just look at this situation. You have deployed an application to Google GKE, and you're using Cloud SQL proxy container to make the Cloud SQL database available to the services running on Kubernetes. You are notified that the application is reporting database connection issues. Your application policies require a post-mortem. That's a very sad word, post-mortem. What should you do? Use gcloud SQL instance restart. Validate that service account used by Cloud SQL proxy container still has the Cloud build editor role. In the GCP console, navigate to the Cloud logging, consult logs for GKE and Cloud SQL. In the GCP console, navigate to Cloud SQL, restore the latest backup, and use kube CTL to restart all pods. That's a specific command. 1 minute, 30 seconds. Let's go. C or C++ or C#? C++. I bet you love it. Very difficult to allocate, how do you call it, memory management. Very difficult. I mean, not impossible, but challenging. Yeah, nice. Yeah, so the correct answer, yes, indeed, is correct. C. It allows to correlate historic GKE sidecar errors with Cloud SQL system logs to find the root cause. I'm not going to say why the other ones don't work in the interest of time, because essentially we have 10 more minutes and I have literally 2 more slides in case you had enough of me and Goran. Just gonna go quickly through this and give you some informations, and pretty much done for the day. So finally, we need to manage who actually has access to our databases using identity and access management roles. Instead of giving everyone full owner access, which is wrong, we strongly discourage, and it's a big no. You should use these predefined roles based on the person's job. So the most 4 common Cloud SQL roles, as you see them on on your left side, we have admin, editor, viewer, client. I'm just going to explain a bit what each one of them can do, but something to remember here is the least privileged access. I'm going to give you an analogy as usual, but let me finish with this. So so for the Cloud SQL admin, this is your DBA team. On the database owner, it provides full control over all Cloud SQL resources in the project, including the ability to delete, create, and modify instances. The editor is the DB operator. It allows full control of existing instances, but with 3 critical restrictions. They cannot modify users, cannot manage SSL certificates, and cannot delete resources. For the viewer, best for audit or security teams, it's strictly read-only. For the Cloud SQL resources, they can see that an instance exists and what the settings are, but they cannot make any changes or connect to the data. And client, this role is used for your applications and the Cloud SQL auth proxy. It does not allow you to manage the instance. It only provides a specific permissions needed to connect to the database. So just again, an exam tip. Always remember the differences between admin, editor. Admin can delete, editor cannot delete, for example. And keep in mind that being YAM Cloud SQL client only gets you through the front door. You still need a database user, account, username, and password, or YAM database authentication to actually query the tables. So as I was saying, the least privileged access, it's, I'm not sure if I can call it a framework, but I think best practices. It's, for example, you go into a restaurant and your waiter would not have the password of performing a refund for a client. You will have to have a supervisor, a manager, and so on. And each one of them would have specific access. The same is here. Just look at this. And yeah, that's pretty much it. Cool. Now, just to summarize, because we've been speaking a lot about Cloud SQL. This is Google's fully managed relational database service for MySQL, Postgres, and SQL Server. So I'm going to go through some key points, and that would be pretty much it. So scaling and performance, availability and recovery, migration, security and connectivity, and access control. So scaling and performance, we can scale this compute instantly with a brief restart or large storage with zero downtime using auto growth, which we mentioned. Availability and recovery, we ensure business continuity through high availability across zones and read replicas across regions. For data protection, we use automated backups combined with point in time. Remember, time travel. To undo human or logical errors down to the second. Migration, moving to the cloud is simplified by database migration DMS, which allows for near zero downtime cutovers from on-prem to GCP. Security and connectivity, we prioritize zero trust by using private IP to keep traffic off the public internet and the Cloud SQL auth proxy to handle YAM-based authentication and encryption automatically. Why should you do it when it's possible for someone else to do it for you? And lastly, access control. We enforce the principle of least privilege, something I've mentioned already, specific for YAM roles, ensuring that only authorized clients can connect and only admins can manage the infrastructure. Waiter, supervisor, manager. yeah, I think that's pretty much it on this. We do have a lot more, but essentially we have what's it called, a study case, isn't it? Or case study. That would be next, and I think this would be essentially their homework. Would you agree with that, Goran?
Yep. This will be the homework, yeah, like you mentioned.
So obviously the slides will be sent to their email addresses. There's an automation already there, so that will happen. Those ones that it will happen for those ones that, let's just say, they have joined. The first time they have joined was this session, because I'm not 100% sure.
Yeah, it will happen for everyone that joined today. Yeah.
Okay, cool. So just have a look at this case study. I'm not going to say to you any more about this, because I think they had enough of us for today. We kind of gave them quite a lot of informations.
Yeah, this is going to be the case study. Then you can go through like a little bit of like architecture and what's the technical solutions that's proposed. You'll have quite a few diagnostic questions and stuff over there. And there is, as always, there's going to be links to useful materials that you will be able to go through at home. But as always, like Stefan mentioned, thanks so much for joining. So we will share the slides. We will share an additional questions as well for you to go to home. We will share the recording as well of this one today that you will be able to access anytime. For anything, feel free to reach out via email to us. But also for any questions, when we see you next week, please do bring it forward during the session, or if you would like to get like a in advance a little bit, yeah, just. And with that, we have 3 more minutes, but I think it's safe to say, have a great evening, everyone.
Take care. Bye-bye. No worries. You're very welcome. I'll see you next week. Make sure you're not late.
Yeah. See you next week. Bye-bye.
Bye.